good. That would be fun. I don't get my email when I'm walking around. Nina, her watch will beep it or whatever. I don't know. I'm going to be the last one with a brain implant.
They're Apple brain implants. I won't get one.
I'm worried if I got an Apple brain implant, every time the next version came out, they wouldn't bother to update. You have to get it replaced every year or two.
That'd be terrible.
Yeah, it would. All right, that's set up too. Okay, if anybody's watching, I guess I can find out if anybody's watching it because it has a participant thing. I feel like I needed to put it up, but now I can't remember who for. All right, did you? Oh, okay. Hey, you weren't the only one on Thursday. I had 3 people on Thursday that needed it. Okay. Today though, all right, let's start with colors, because I think colors will be kind of a fun addition, and I may even use them today. All right, so when printing out stuff in colors, you can see my terminal up there is in color, and maybe colors are handy. So I have this color library that's a C one that I probably talked about in cs-253, and it's, like lots of people have borrowed it. I was just highlighting it, and I realized it wasn't even my directory I was highlighting it from. I'm not even sure I see my directory on here. Do I have it for me? No, I don't.
Isn't that an assignment? Like, we have to do something with it?
I don't think so. Wait, why is it? Oh, that's right.
Why would I have copied it then?
I copied all the examples.
All right, well anyway, here's an example of my color library. I'll put it in our examples. My software, public, HTML, and cs-311 examples. All right, this isn't the one I want to show you for this class necessarily. I just want to start there real quick, giving a history. I always think these stories about the origin of various little programs I wrote are very, very interesting, but they're actually only interesting to me. Luckily, I realized this enough not to put questions about them on the test. All right, so terminal color codes look an awful lot like this. And so if I take one of these terminal color codes here, and there's the red one, for example, and copy it, and put it right here. Oh, if I copy it in a way that works over SSH, not black, red, it should print out a red X, maybe quotation marks. No, it didn't. Interesting. Maybe I put up all quotes. It doesn't even work there. Interesting. All right, I thought that would work, but apparently it doesn't. Okay, so these codes here, this /x1b, etc., 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 direct the terminal to switch colors. Apparently in some way that doesn't work. Oh, I know. I have to echo it. There we go. Kind of. I got to take this off so that it actually interprets it as a color code. I don't know. Whatever. All right. Because it's got this semicolon in it. Well, it's a little complicated to use them like that, so we won't use them like that. All right. So if I want to use it in C, this should be quotation marks, because it's actually just a file in the same directory. All right. Okay, then we can say printf, this is in red. All right, but we want it to actually be in red, so we say red, like that. That needs to have 2 ends, because we have the red thing ending right there, printf ending right there. All right. There we go. This is in red. Cool. So I wanted one that would work like that for C++. But the problem with the C++ one is if you take this library and put it in a C++ program, I don't believe it works. It's the problem with string concatenation. If I say colors.cpp, I will include iostream and then include colors.h. Sorry, it takes a moment. There, that. So we'll take this, this is in red, and put it in red, and I think, if I'm not mistaken today, CPP, it will not work. Oh, it's called scolor, sorry. There. See out not declared as scope, that's different. You ever get that error message? It means you didn't use namespace standard.
I literally always get it.
Alright, so we have this whole thing here, unable to find string literal operator X with const char 14, basically this long type error involving this expansion of macro and whatnot. So this approach does not work in C++. Alright, so if I look for scolor.hpp, I've got a few of them there, and I should be able to scolor, I've got one on 3D stack there. This one, HPP, what we're doing here, it comes out a lot longer in C++ here, but basically we're taking the terminal color code and turning it into a string, and then adding on the string X from this macro. So I'm going to say define black X, this is going to be basically cut and paste. We'll take this and cut and paste this in instead. And this runs before the compiler, so the compiler won't have actually built this yet. So before the compiler runs, we're going to make that substitution. X goes there, and then after that, we've got the string there that returns the terminal the normal color. Alright, comes out a little longer. std : string, I didn't want this to include namespace standard. Not every programmer likes to use namespace standard. Sometimes some people prefer to just specify when they need something in the standard namespace. So this way the option is available. You can use it either way. Alright, it won't cause a problem if you did use namespace standard. Alright, and so what do I call it? Colors.cpp. Okay, so we call the HPP version right up here, and run it. There we go. This is in red. Cool. And so this should work for any of the colors. Green. Alright, there's green. See if that works. Yeah, there we go. That's in green. Alright, so either one works there just fine. One note about this one, colors.hpp. Oh, this color. There's the regular versions of the colors, then there's the bold versions of the colors, and then there's the dark versions of the colors. And sometimes they don't quite come out the way you might expect, but maybe you feel like using a library, you can play with it and see what happens. Basically, the number on that is up here, whether it's 0, 1, or 2. Yeah?
Can you concatenate different strings in the same cout statement with different colors and have it still work?
Yeah, so if we wanted to do that, we could say something like, say D green, that's dark green. This is dark green, and then they could say something like, you mean with this operator or with plus?
Like you had the first time, so first time that you.
All right.
No way, dude. That's the first time I've ever called that.
That's called the insertion operator. All right, there we go. So that kind of thing?
Yep.
Yeah, that should work fine. There we go. Okay, well anyway, sometimes this can be handy. I tend to use it in programs to, when I'm looking for something. Now, if you got a rare error condition and you're like, I think this happens sometimes, you can print it out in red and then you can see it quicker. Yeah. All right, so we'll use it for our next demo. All right, we'll talk about operators. Operators are fun. Okay, that should be any course examples there. Yep. And so the colors HPP. HPP has not gained a lot of market traction. Most C++ headers just in .h. But for a while that was proposed and accepted. I mean, it was used, still used sometimes. As a note to demonstrate, the same way we go from .c to .cpp, that this is C++ exclusive and you should not give it to a C compiler. All right. Operators. Operators are not posted. Why do I never maintain my website on time? This is why I don't teach web dev. I can't even remember to post stuff when I write it. Alright, if anybody ever hired me to maintain their website, they'd be in trouble. Alright. Alright, so question for you. Did you overload operators in C++ and cs-311? Did you mean yes, or?
I'm pretty sure we did.
Okay.
Only said no,
Probably
so I agree
did.
with her.
It sounds familiar.
Okay.
Fast today, so.
lot of you asleep one of the last days of the semester? All right, well, let's start with how you overload operators, and some of you will have a reminder instead of anything. All right, I have this weird int demo. I want to show you that first. That's what I said. I think so. Weird int. All right, so here's my weird int demo. I'll go ahead and copy it to the spot for this course. Okay, lecture4 cs-311 examples. All right, we can build it from here. Okay, g++ weird int.cpp. Oh, that's right, I put that in there. I was playing with it the other day to show you something, and I think I might have left it in there, and so we'll take care of that later. All right. I might have put that there for that. All right, so here's a program here, and we made a weird int called x, and then we assign x to 5. So that's the value of x. Then we say y is x, so copy the value of x to y. Then we print out y, and then we print out 4 plus x and x plus 4. So if x is the same as y, you'd expect us to get 9 in both cases here. 4 plus x, which is 5, should be 9. Same thing with the other. As you can tell from the comments, that's not going to happen. So if I run it here, you can see that it prints out 42 for this second arithmetic operation here. All right, so here's the definition of a weird int. We've got a value up here called val, and we've got this inline operator plus right up there. You don't have to make these things inline. I've put inline there before to explain what inline is, but let me just take it out on one of them, and you'll see it works just fine even without inline. See? All right, same thing. Inline is a director to the compiler that tells it that this function is so simple that you really shouldn't make a brand new function call for it and deal with calling the function. That's way too much headache for this. Just like put a 42 everywhere you see this function call. Now the compiler should figure that out anyway, so it's not really that necessary a keyword. But if you don't trust your optimizer, you can throw inline in there. All right, so the name of the function here is operator plus. And the parameters that the function takes is this int other. And that's what we're going to add onto it, or I guess we could add it onto our current one. We're not here. We're actually ignoring that one completely. But the operator plus does take an other there. We've also got an operator equals down here. And the operator equals changes the val that we're currently storing. I can turn that back to private in a minute here. All right, so there's operators are basically the same thing as functions. Oh, and in this one down here, this operator int parentheses. All right, this one probably looks a little weird because we didn't really give this one I don't know, the name's kind of embedded in here, and there's not really any return value. This is the casting operator, and so this is the operator that converts the value to integers. I'll go ahead and comment this one out here real quick. All right. See, we got a wall of text from commenting that out. In fact, you might be like, it wasn't that bad. Did it really justify all of that? Where does this even come from? All right. So this is probably the critical error right up here, the results when we comment this out. Cannot convert weird int to int in initialization. All right, it gives us this line right here. This is an initialization because we're initializing y. So in order to initialize y, which is an int, we need another int. But what we have is a weird int, not an int. These are different things, so we can't do this initialization. So that's where it stems from, and it finds the same error in a lot of other places like this. And so we see the error kind of cascade down all the way. All right, so it's a casting operator. Essentially, when we say int in parentheses to cast it, or when we implicitly cast it, this function will be run. So you can look at this and be like, well, how many times does that run? Probably kind of often. Just say cout casting val to int. All right. And that one right there. Okay. It should run actually a few times. I'll go ahead and build it here. See if it looks great now. Casting 5 to int, casting 5 to int, later casting 100 to int. So anytime that we need an int instead of a weird int, that operator there is actually the thing that's running. And so actually if we wanted to, say, print out, I don't know, 165 every time instead of whatever it actually is, if we return 165 here, there we go. Now, it's either 165 or, in this case, it was converted to an int and then 4 was added to it, so we get 169. You know, either way, that's what we've decided its value is now. Okay. So that's the conversion one. All right, so these other ones up here, you might notice that there's sort of a strange deal going on here. You know, one of these is different than the other. And the only difference in these lines is this ordering right in here. There's not some trick, it's just the order there. So 4 plus 5 is 9. That's because, so we have 4 here, that's an integer. And then we're using plus to combine it with a weird int. Well, a weird int is not an integer, but we can convert a weird int to an integer because we have this method right up here where we can convert it. So since we can convert weird int to an integer, then if we convert our weird int to an integer, we've got an arithmetic operation, and we can go ahead and do this addition. So that's the way the compiler has resolved this little line here, 4 plus x, where x is a weird int. All right, now down here, we've got a weird int, and is there any way we could go ahead and add a weird int and an integer? And so what is found is this one right up here. If we have a weird int and we're adding an integer to it, we can do it just like this. So that ends up being run in, I'm sorry, I highlighted the wrong one. This one right here. We got an operator, plus here, for weird int, and we're adding an int onto it. So, weird int plus an int, this is how we do it. And what we'll get back from that is an int. That's very convenient because cout can print out ints. So that's what's happening down here. So when we say the weird int plus the regular int, we mean that method up there. This simply returns 42 regardless of what the actual arithmetic is. All right, so I made this as kind of a weird demo actually of the way these things work. Oh, and this part down here, this can totally be private. The only thing is when it's not private, you can't do that. Do this if val is private. But you can do this instead. You can say x equals 100. I think we've got assignment described right up here. So we'll end up running this operator right here, which changes our val to data right there. We're returning this pointer. The operator equals is expected to return the same type as it assigns. If you have something where you said like if x equals 5, what we're doing here, we assign 5 to x, but then the result of this whole expression is type int. Assuming, sorry, I have weird int over there. I'm assuming that we got this up here. Sorry. All right, so we got x, and x is an integer, and we've done this. Then what we're going to get back is an integer. However, if x is a weird int, then what we get back is a weird int. And you could actually have it return some different type, but that would be a little bit unusual. Usually you return the same type as you're assigning. All right, so this one right here evaluates to if 5, and 5 is true. Okay, so there's a kind of a brief example of operator overloading. All right, now looking at this, I put this note in here. So x is 5 and 4 plus x is 9, and x plus 4 is 42. This kind of thing should be avoided. It makes programs confusing. Try not to write confusing programs. Eventually you confuse yourself. Unless you're writing a program for your friend as a confusing example or something. Which can totally be done. Pretty fun. Here, I'll write a program and you see if you can tell me what it does, and then we'll switch. Good fun game. Do that one before the midterm and the final. That's a great studying game, actually. Because I kind of do that on tests sometimes. Probably not this exact one, but I don't know. Most of the time my programs aren't intended to be too confusing, but sometimes they are. If you're used to entangling mysteries. Alright, anyway. So there's, I guess, kind of an example of these things, but let's try and use one for some productive purpose. And try and overload a couple of things for the linked list that we were working on earlier. Because that could be pretty fun to have. Alright, so the square brackets. The square brackets are usually used to give some kind of index. You know, you see like some array at some position, and so they're an operator, and we can overload them. So what do I have here? We had a word list that we were working on earlier. Yeah, there's our word list. All right, so an operator. That's how we say that operator. And what we're going to return from it, a word list example from last time, we're restoring. We have a list of strings. So each word list node has a string data, and it's got a word list node that points to the next thing in the list. So that was how our chain worked there. All right, so what this one will return is going to be a single string from the list. So if we've got a list of words, we'll go ahead and return some index. All right. And what's it take for a parameter? Well, normally when you say something like, you know, your list and this, you know, 2, I mean, that's your parameter right there. And it's an int, but we might be better to call it a size t or some kind of more specific int. If we say something like int item there, or I, or something like that, I mean, that's fine, index. But if we have a list that's longer than 2 to the 32 items, then we might want a size t, which matches the memory size on the machine. For an index like this, you don't really go wrong with a size t, because if your program sticks around until we make it to 128-bit addressing, your program will still work. Size t will just change its definition. That said, that'll probably be a long time. Although people are probably saying that when we move from 16 to 32. I mean, there's probably some past version of myself that said the exact same thing as that in the 80s, you know? Technology always changes. All right, so we'll have some kind of index here. And so, kind of a review of how these linked lists work, which might be interesting if you've started on project 1. We're going to have some kind of node that's pointed to by start. I think I called it start. Yeah, I call it start. Sometimes they're called start, and sometimes they're called head. Either one is fine. But I think this one's called start. All right. And so we got this node there that's going to have data, and it's going to have next. And the next is a pointer that points off somewhere to some other node that has data, and it has a next, and that might point off somewhere else. So we're going to get item number, you know, whatever it is. I mean, that one up here, this would be item 0, this would be item 1. If there's another one over here, it would be item 2, and so on and so forth, all the way down. All right, so let's go ahead and make a little loop here. All right, so we need to keep track of where we are. We'll start at the start. That's a pretty good place to start. And then we need to keep going while we'll have a counter here. So we'll say something like index minus minus or something like that. Like, well, there's more space left on the index. We want to say place equals place next. All right, I don't think I actually used those. And so we iterate on index times, and then we should be in the right spot. So we can say something like return place data. All right, let's try it out. All right, so one of the things for the assignment, you have to put in test code to test everything. And so, I mean, here's my example for my new operator brackets then. We'll say cout, say item 0, and we'll print out places at position 0. All right. And then it's just somewhere in the middle. So let's say it's like item 3 or something, places position 3, and then lastly, what if we pick 100? Probably gonna crash. All right. Oh, that's weird. All right, so there we go. So item 0 in this list here is behind the dumpster near the McDonald's. Where are all these things? Then item 3, 0, 1, 2, 3. IBMLH 310. So that's correct. But then we get a segmentation fault when we go past it.
There
Well-
is no item 100.
Right. Now, in a sense, that might be fine. I mean, what do you get if you go past the end of an array? Segmentation fault, right? I mean, if a regular array and I ask for an item that's past the end, well, maybe. I might also get what's past there in memory, I guess. But anyway, so, I mean, normally, lists kind of crash in that case. Now, we could say something here, up here, like, well, this, and place next, like, well, there is a next place. If we do that, we'll probably end up returning the last value, for ones that are too high. So, you see it just, item 100 is the last thing in the list, is the Pullman. But, this is kind of a behavior, I mean, what should the linked list class do here, right? I mean, it's kind of just a behavior question, what's expected on this one. We could legitimately make a number of choices right there. All right, I'll leave it this way. Perhaps the best thing we could do actually is throw an exception. Let's not do exceptions today. But that could work too. All right. So I'm going to do another operator here. Oh, yeah, the insertion operator. All right. So there's an example of how to take care of this sort of operator here, where you add it. You notice it's actually really simple in a way. The operators have names that you use instead of the regular function name. Instead of the name of the method there or function, you just say operator, whatever it is. And then the parameters are usually whatever you'd expect the operator to have. I mean, with this one, you usually expect an integer type of some sort here. This is an integer type. It's a 64-bit unsigned integer. Then you just use it like a regular one, and you return whatever you want to return. So they're not too hard to use. All right, let's use the insertion. Now, here's the difficulty with the insertion operator. If you say something like cout insertion, and then you give it something over here, and we're going to give it some kind of word list, something like, I don't know, places. All right, so expect to do something like that. Well, one of the difficulties when we do this is places is actually the thing on the right side of the operator, and cout is on the left side. So you saw with the weird int, when the integer was on the left and the weird int was on the right, we end up calling the integers addition. So following that logic through here, that kind of means the operator belongs to the one on the left. So what we've got here is not an operator that we're adding to our word list, but an operator we want to add to cout. See what the difficulty is there? Like, we're not going to go in and modify cout to support our particular class. That'd be a little odd. Okay, so we can still do it, but we can't just make it a member of this class up here. It's not going to be quite that simple. So we can say something like, all right, the type for cout, cout is derived from a class called ostream, which is an output stream. So that's what type it is. All right, so. That's right. So we're going to make an operator. It's going to return an ostream. You notice when you cout a bunch of stuff together, cout something, 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 it keeps working. That's because that insertion operator returns an ostream object. So we got to return that operator, and then as its arguments here, we're going to take an ostream by reference. Actually, that's how the operator here normally works. And then we're going to take one of our own ones. And it can be a const one, so const word list reference. These have to have names here. I'll call this out, and I'll call this one WL. All right. So we've got WL and we've got out right here. So I'll go ahead and print out the first thing just to get started, and we'll get the rest of this thing together in a minute. So I'll say out, and we'll go ahead and insert something like WL at position 0. And maybe an end line. Maybe some text. All right, there we go. All right, we're going to return out. That's what we had here, that same O stream. And let's see what happens. Oh, we need a test. We test to see if it works. Cout, places, and line. All right, let's see what comes out as the last line here. I had a few errors here. Passing const wordless as this argument discards qualifiers. You may have seen this with lab 2 with the squirrels. And you may remember the solution there is instead of a const wordless, we want to add const right up here. Oops. Because this operator is not changing what's at any of these locations. Now, we might want it to be able to, but that's a different operator. All right, use a deleted function. What are we looking at? Basic O string.
Return out.
Yeah. All right. I don't think we want a const O string because we're going to modify it. Let me make sure that's not it. Nope.
Didn't you want to take out the const on wordless there?
Right here?
Yeah.
Well, we could. If we take out const on word list and take out this const up here, that also avoids our const problem, because now neither one's const. But it still leaves us with our other problem right here. Use a deleted function, which looks like an O stream something. Maybe it's not if I reference O stream. Or maybe we need to return a reference to an O stream. That might be it. There we go.
Yeah.
All right, so we're printing behind the dumpster near the McDonald's. Yeah, that was the last thing on the list there. We ended up with an extra new line, so I put an end line there, and I put an end line there. But we want to go ahead and print out the whole thing. All right, now this runs us into a little bit of a private data issue. So one thing that might be real tempting, so we've got this print right up here, and that prints out the whole thing. Go ahead and grab the guts out of this one and put them right down here. All right, we'll take out this silly one right there, and I'll take out an indentation level. All right. Now, I called this out right up here, and I called this one cout. So let's change to out. All right. And let's see what happens. Nothing good, I'm afraid. Start was not declared in this scope. Suggested alternative short. That's not going to help. All right, so here's the problem. The reason this code worked before is that it's up there in part of the word list, like the linked list, word list up there. And so when we moved it down here, it's like, well, we don't know anything about start. And so if we look, what is start? I mean, start is this word list node right up here. And so down here, we can say, all right, well, let's say it's WL's start. WL dot start. Let's go ahead and grab that. All right. Now it mentions it's private within this context. Yeah, it is. All right, so a couple of ways we could do this. One way we could do it is put in a way inside the class that it turns things into a string. That might be the best way, because then we can also have a toString kind of method up there that converts things. And that could actually be kind of cool to have around. The other way we could do it is we could change this operator here so that it is a friend operator. All right, now it is a friend operator. So the declaration there looks exactly the same as this, except that I decided to omit the names. You can do that if you want to in these. It has a semicolon instead of starting with an opening brace, and it says friend at the beginning. Other than that, it should be the same. All right. Now you can see the whole thing works, and it builds, and look at that, it even works. It printed out the right thing.
That's not too bad.
What's the friend operator?
All right, so the friend here, you notice that the friend changed whether or not that we could access this. So when I comment this out, we'll be back to the can't build it because of the the WL start is private within this context right there. All right, let me explain friend. A friend may be somebody that you allow a greater access to things that you control. For example, when I leave town and I go away for a week or two, next door I have a friend, and she's 11, and she takes care of the goats and the cat and everything in the house, and so because she's my friend, she gets to wander around the house. She's kind of more my daughter's friend than my friend. I mean, they're the ones that play together and have tea parties together. But, you know, by and large, she's acting as a friend here. So, on the other hand, if somebody wasn't my friend, I might not be okay with them wandering around my house while I was gone. So, a friend function is allowed to access data that would otherwise be private within this class. So they're allowed privileged access to the private data members of this particular class. The same way that you might allow a friend access to your house or car or whatever. All right, that's what is friend. The textbook had some funny explanation about friends and private parts that made everybody giggle and blush. I don't remember what it was, but I've never been tempted to copy it. Anyway, so the friend access allows private data access right up here in the class. Yeah.
So what's the practical difference between using that solution versus just using a getter function to just return the value?
So right now we don't have a good getter function on the menu for this one. We've got our operator brackets and they work, but if you think about the time complexity on the operator brackets, we got to start at the beginning and go to whatever we want, then we return the value. Then we start at the beginning, go to whatever we want, return the value. Start at the beginning, go to, yeah. So it's going to have a greater time complexity if we use our operator with the bracket signs. That said, we could have some different kind of getter that would solve the problem more gracefully. Yeah. And so, actually, your other your proposed idea there, well, why don't we just figure out some way to convert it to a string? That's a pretty good solution. Here's how that one would come out. We could say something like string operator, and we want the parentheses sign. How did that come out again? Let me cheat for a moment. All right. So we just say operator, and then we say what we want to cast it to. All right. All right. So that string is out of place right there. Or not that one. There we go. Operator string. Okay, so this has to return some kind of string. We'll go ahead and just test it real quick. Hi. All right. And so then I'm going to go ahead and comment out this part of the solution and all of this part of the solution. All right. Dude. No match for operator insertion. With a word list. Why didn't it convert to a string? What if I try to cast it? Now we're fine. All right, there's hi. All right, we don't necessarily want to cast it, but we can take care of that in a minute. All right, so then the way we were assembling this whole thing basically works like that, except that instead we're going to go ahead and assemble a string. All right, turn out what we want to do. We're going to turn out string, so make some kind of string ret val equals nothing. That plus equals that. And then it's going to have to plus equal this. Plus equals that. Plus that. And now we might not want these backspaces in there if we're doing a string. The reason is they might just be, we don't know what the user's going to do with the string, right? I mean, the backspaces are cool because they're terminal control characters. I think this might work. almost. WL, now let's see, WL starts, we're inside the class now. Hi. Am I still returning hi?
Yeah.
Mhm.
Yeah, you're right. All right. All right. So that must, or which one's it? It must be this right here. There. There's S color. Come down here. We'll go ahead and print this out and say green. All right. What? I thought I put it here.
You didn't do the include.
Oh. You can install them into your system library and not have to do this anymore. Or you can actually say GCC and -I and add an include path to it too. That also turns how you do that. All right, yeah, that's the one. See, that's the green one. All right, so it worked and it looked pretty good. I didn't have to do this cast there. See the cast right there to a string. No, maybe you don't want that. We can put a different definition right down here. We could say something like OStream operator and OStream out word list WL, and what we'll say down here is just return out, and we'll put into it the WL. Oh, string. There we go. All right, so we'll convert it to a string. In this context, it's kind of unexpected for it to come with a new line, so I might go ahead and drop the new line. And actually, in the string conversion context, anyway, it's kind of just, I don't know, when you put something into one of these streams, you assume that you're not getting a new line until you say you are. So down here, you can see I even put an E and DL there that I didn't really need. So I can say something like WL places equals places. There we go. Yeah, I'll make this one red. I'm enjoying having that color library.
Mhm.
There you go. Places equals. There it is.
Well, it made places red and.
Well, yeah, see the way I did this, I didn't color the places right there. If I do, all right, well, let's just try it. Let's see. Hey, it totally works. Although that works in a little bit different way. We're actually not using our OStream operator anymore when we say blue places there. So let me show you. All right, so suppose I go ahead and get rid of this right here. All right, then up here, we're going to go ahead and comment out our OStream operator completely. Doesn't exist anymore. We should get a problem here. All right. Boy, do we ever get a problem. That goes on and on and on. Dude, there we go. All right, no match for operator insertion when you have an OStream and a word list. Now you might say, but can it turn places into a string and make this work? The answer is, it won't figure that out. All right, so suppose I decide to make it blue again. It's part of the reason I didn't make it blue initially. All right, there we go. Let's try it again. Hey, everything's fine. You're frowning, like why in the world would that change anything? Here's why. So if you take a look in the in the header right here, blue takes this string, and then we call plus, and we add on this thing that's being explicitly cast as a string.
I see.
And so because we're converting it to a string, that kind of two-string cast that we put together is happening for us, and we're turning it into a string, and then blue is adding these things on. You know, it's getting all this stuff added onto it, but it's made into a string. Yeah. But you know, people wouldn't necessarily expect to have to use a color function to print something out. Like that'd be a little weird.
Yeah.
You should expect that you know, places that should work. I mean, that's probably the first thing people are gonna type here, right? And, so that'll only work if we commented out, or uncommented this one right here. Alright. There we go. Looks pretty good. Yeah, so, I mean, that's kind of your question, right? Like, why not just do that? Do you like the way it came out better this way, or you like the other way?
I guess, well, I think my question was like, so you know, like, you could just make a function in the word list class,
Mm-hmm.
just called like get start, and it returns a pointer to a word list node, and you could just do return start.
Yeah,
Instead
you
of
could.
having that function do wl.start, accessing the member like directly, just do wl.getStart,
Mhm.
and it, you know, like, is there really any preferred way to do that?
That would work fine, and there's even a justification for it. In a sense, doing that is kind of like just undoing the private thing. Because if you don't want it to be hidden, then why not just make it public? However, your getter is not going to allow you to change it. So if it were truly public, you could get yourself into some big trouble here if you did something like, alright, so here's our word list. I'm just going to go ahead and move public up for a minute. So by making this thing public, this start, somebody can come down here and say something like places.start equals, I don't know, 157. Alright, go ahead and build that. Invalid conversion from int to word node list star. Well, we're determined today. Alright. Word node list is not declared. Oh, is it word list node? Probably word list node. Like I said, we're determined. Look at that.
Yeah.
Segmentation fault. Alright, well, it's a segmentation fault because we want to change the memory pointer to point to address 157, whatever happens to be there. And apparently that wasn't a good address for us to change it to. We can also do, now, somebody might try to do this for something for, you know, like productive. They might say, alright, this will be a reset. We'll even comment on it. Alright. And we'll go ahead and add a new place. And, alright, there we go. So we build it and run it, and hey, look at that.
Everything.
All of a sudden, the only thing in the list is my house. Cool. We can add it whatever we want. There, now we got two things in it. Alright, cool. Alright, well anyway, so you can see somebody trying to do something like that. And we don't really have a method to clean out the whole thing in here anywhere. We can delete individual items, so we could repeatedly, we have a delete? No, we don't have a delete. You have to write the delete for the class one. Alright, we don't even have a way to delete items. So you can see how somebody might be like, well, I'm just going to go ahead and implement this as a way to clean it out. And then they could be looking at this and they could be like, hey, this is cool. This works. He's still sorted even. You know, the place my goat is right now came out in the center because it starts with T. But let's take a look at Valgrind here. Oops, not Valgrind. All right, the leak detector. Oh, we've got a memory leak.
A little bit.
Yeah. Well, you know, we can see where the memory leak's coming from here, because when we're busy doing this right here, this like reset places thing, we're basically abandoning all of these things. That's our memory leak. We're never freeing them. The compiler apparently hasn't figured out that we've lost them because it hasn't thrown any kind of warning, but I mean, how would it? So we've really kind of sabotaged the functioning of this class. All right, but you know, your suggestion earlier, having an accessor, I mean, that's not going to be any trouble here because we could say something like, say get start. All right, this is going to return a word list node star get start, and I'll give it any parameters. All right. If we do this, we're going to get back a start that's a copy of it, because we're returning an address, but we're returning the address by value, like we're returning a copy of the address. So if we do this, and we're like, all right, so we run this, and oh man, you can't do that anymore? Well, we'll fix them. This will take care of it. We're going to say this instead. Dot, what do they call it? Get start?
Get start, yeah.
All right. Can't do that anymore. Too bad. We'll try this other way. Oh, man. We need an L value. We can do that. We can fix this. We can do determine. Equals. Let's do that. All right. Maybe. We're barking up the wrong tree. So I've been talking about the whole copy thing. You see, we didn't actually manage to affect the contents of word list at all. Because all we got back was a copy of the address. Suppose you saw somebody, and you know that every night they get in a Rolls Royce and they drive back to their house. And you look at their car, in the middle of the steering wheel, you see a piece of paper there with a piece of tape, and it has an address written on it. And it happens this is the address of their house where they go every night. So you're like, oh, this is clever. So you change the address, and then they go somewhere else if somebody steals their car. You know, that worked great. But if, on the other hand, you wrote down their address on a piece of paper and changed your piece of paper, well, that's no help at all. All right, probably more explanation than you wanted. I just wanted to explain what's going on there with that. Looking at this, I mean, this is,
So,
yeah.
can't you do like, can't you modify start then? Because if you can return it, can't you make a function that modifies start?
Down here? Well, I mean, we kind of tried that, didn't we?
Wait, I'm so confused on that.
All right, so these,
Well, 'cause like the function up there just return start, right? Is there no way that we can make a function inside of public that can?
so when you have a function like this, and it has a return value like that, what happens on x86, and this is similar to other platforms, is we take wherever our start is, we copy the value from start into a register, and then we return from the function. After the function is returned, wherever we are back in main, picks up that value out of the register and goes ahead and starts working with it. Let's see, it's a copy of wherever start was actually stored for the class.
Oh, no, I understand that, yeah. I was just confused, like, can't you do like start equals something, something?
Oh, like right here?
Yeah.
Well, yeah, but I'm inside the class here. I mean, if I say something here like start equals 100, yeah, I mean, that'll break everything.
Oh, okay, I get it now. Thank you.
Yeah.
Sorry. I was just confused.
Oh, okay. Yeah, there we go. And you can always sabotage your class from inside your class.
Yeah.
I mean, it's like trying to prevent somebody from breaking into your house from inside your house, you know?
That's a good idea.
What's that?
That's a good idea.
Well, I mean, and, you know, the standard Idaho solution for that is firearms, of course. It's reasonably effective if you watch the news.
Nice.
My mother-in-law is very, very, very concerned about criminals, like really concerned about criminals, like hopelessly paranoid about criminals. I, on the other hand, never even bother to walk my vehicles. So once she's like, you really gotta be more careful, I'm like, it's Idaho, we shot all our criminals. And I sent her this link to this coffee stand robbery up in Coeur d'Alene, where the coffee stand was being robbed, and so the barista pulled out a gun and shot the intruder. I'm like, look, this is what happens to our criminals around here. She didn't quite believe me. Anyway. But she lives in Oak Harbor, and so that's a different place. That's not Idaho. It is off the I-5 corridor. She bought that specifically because she figured it would be a very safe community. It's also right next to a Navy base. All right, anyway, so back to the data protection and classes. So there's a few different things you can do with this operator insertion and different ways to do it. You see this solution with a friend function semi-regularly, especially in textbooks. I think just about every textbook has almost exactly this example in it somewhere. I'm not sure what page it's on ours. I didn't to go look for it exactly. I just verified the book had about the right contents. Probably chapter 11 with the more object-oriented programming. Yeah.
I know that passing a multi-dimensional array of variable size to a function is really difficult. Could using friend help with that?
If you're passing a class to it, and the class holds a multidimensional array, then you could give access to that class to whatever function you're writing.
This is class.
Yeah, so I mean that could help, but either way, the difficulty with a multidimensional array, so a multidimensional array gives you kind of a complicated memory layout. And the memory addresses are linear. So a lot of times in the multidimensional array, somebody will come up here and draw it like this, where you're like, all right, this is my multidimensional array. But this is like our visualization of it. Inside the computer, it's all going to be in a line. And so the basic things you need to pass in are, first of all, the address right there. Like, where does this whole thing start? And then since it's all actually going to be in a line, you also have to pass in, like, how long are these things? Like, what is the row width, or sometimes it's referred to as a stride. That's about impossible to read, but I wrote stride there. Basically the length of each row before we come back over here. And then sometimes you might also have to pass in, how big is it actually from beginning to end? Or like how many rows do we have, or what's the total length, either way. And so if you wanted to represent one of these things as a class, you could say something like this, class multi-array. And then for private data, you could say something like, I don't know, suppose it's an array of integers. Point, and then you'll initialize it on the heap or something like that. Then you could say something like size t row len and size t total size or something like that. And then if you just passed in the class and whatever you're passing it to had access to these members, then you have all the information at once. Yeah, I'm assuming here in the constructor, you end up doing something where you say like, suppose this is a constructor, say start point equals malloc, well probably not malloc, new, whatever you're making. Yeah. Yeah. So yeah, sure, you could. You might not need friend though, because it might be that you want to make whatever method it is part of the class anyway, and so then you wouldn't need it. It's only if you're wanting a function outside the class. Yeah. Any other questions? You got some good questions today.
Yeah, this is something that's been bugging me. So for the first operator, like, can we maybe have the brackets there? And the O-string one doesn't have it, so it doesn't really matter, right? Like, it's not like topology to use that? The operator?
All right, so the O-string one,
I think you hit it out.
right down here where I have this one, or?
No, the square, the actual square bracket.
Oh, right here.
Yeah,
That's because I'm doing the operator, like I'm doing this operator that has them on it.
okay.
So down here, I'm doing the casting operator, like converting it to a string. And then if I had something else, like, one way you might want to be able to add stuff on is like with a plus equals or something. So if I was overloading that one with plus equals, I'd say something like word list, maybe by reference, operator plus equals. So what you have here is just whichever operator you intend to use.
Oh, okay, got it. So it doesn't matter. Okay. It's just
Yeah.
an operator.
Yeah, that's the usual syntax for it. All right. So in terms of when these things are useful, these things are used an awful lot in collections. So let's go ahead, just a brief introduction to C++ STL vector. If I say C++ STL vector, C++.com is probably the most common reference here for this stuff. And so it'll have a lot of container properties and members and whatnot. But you can see we've got members, we've got a constructor, a destructor, and an operator equals that we can use to assign content to this vector. We've got element access. We've got an at method where you can say your vector.at. but we've also got our operator brackets there. It's not a box, it's actually a bracket, and then the bracket, they just kind of close together there. Just like my daughter sleeping underneath a giant horse watering trough that's sealed against the carpet, which I told her not to do yesterday. Then we've got some relational operators and whatnot, relational operators for vectors. And so we have double equals and not equals and less than, greater than, and whatnot. But in each of the cases, that's basically the format you use. So you just name the method operator, whatever operator you want it to be. And then you make the parameters whatever you'd expect for whatever that operator is. Oh, and one other thing, as long as I've got this open, with your question, you asked me, well, what if we just return a pointer to the thing? This has a way to get the pointer back out of it for the vector. Now I forget what it's called. I've used it a number of times, and it is all in contiguous storage. And there it is, data, access data. This method data here, it takes whatever value type you've got on here, and it returns a direct pointer to the memory array used internally by the vector to store its own elements. In fact, you probably could take that pointer and start changing your vector's contents based on it. What we didn't do, you're asking, well, can't you change anything? We didn't try changing the stuff pointed to by the pointer that was returned. We could have done that. All right. Anyway, so there actually is the same thing we just put in there.
Change the what? Change the value?
All right. So down here, I was saying, well, we can't really change where if we change the start right down here, you can see it doesn't do any good. All right. But what if we were to change, instead of that, we change the start and dot without arrow. This is the memory address, next. That should actually truncate the list starting with the first one. All right. See how it I truncated it? Now we've just got one item left from the original list. I forgot about that. The reason that works, so we returned, we couldn't change the start pointer there, but we could change the next pointer for the thing the start pointer points to, like this thing right here, which would truncate everything but the first one. And in fact, thinking about it, we might even be able to do the whole thing here if we wanted to. So that gets rid of everything there. Well, let's go ahead and truncate it completely right at this point if we can. If we say the address of places, and then we go ahead and cast it as a word list node star, and then, so places is going to have, all right, take the address of places, now we're going to change that to 0. Let's see if it works. Said it's an invalid L value. I feel like it should be okay. Take the address of places, change the thing that's there. That's the only data item we have. All right. I'm not sure what's why that's not working straight up. I sort of feel like it ought to. Maybe it's not fully cast by the time we're making the assignment. No, still not null value. All right, I think if you worked at this hard enough, eventually you could get it to work, if you really wanted to. Now all of a sudden I feel like I should get it to work, but yeah. Actually, what we really want to do is change places to 0. So if we change places to say a size t, which should be fine, that's the memory address. All right. That's what we want to say, basically. Nope. Invalid cast from word list So that's why we end up saying a size t star, and the address of places, we're going to change the thing that's that's what I forgot. There we go. We trimmed it down to nothing. Then we put the one item, place where my goat is right now, onto it. All right. All right. Yeah, sufficient creativity. That's the answer to your question there. All right, this should probably go away. It's a little bit of an abomination. Basically what we did, we said, all right, we've got places here, right? You know, places is a word list. What is a word list? A word list is a 64-bit unsigned integer. You realize that? That's what it is. We can tell that. So we go up here, we can see that word list has a single data item, and the single data item is a 64-bit unsigned integer. I know that because the memory addresses on this platform are 64-bit unsigned integers. That's what a pointer is on here. This class, although it's got all this behavior defined, the only data that the class actually has is one memory address. So therefore, this whole class boils down to one 64-bit integer. That's the size of the class. The rest of it's just code. It's going to be stored in the code segment of the program and is accessible using all of these rules. All right, so since the class boils down to nothing but one 64-bit unsigned integer, we can go down here and we can say, let's take the thing that's at the address that this word list is, and we'll say that it's a point, the address is the address of a size t, a 64-bit unsigned integer. Then we'll change the thing that's at that address to 0. Why do we have to go through the address and address of? Because I think if I take the address and address of thing out, the compiler will catch us, basically. Yeah. So that's where we get to the kind of address and address of things. All right. And so we'll go ahead and change that to 0. So what do we change to 0? We change the class to 0. And the class has merely this one pointer. And when that pointer is 0, that's the initial start point for the class. Like, that's how everything starts, is with this pointer 0. So we're returning it to its initial state. We're still leaking memory. All right. So if I run this thing in Valgrind, all right, yeah, a bunch of stuff is lost. All right, so I'm going to go ahead and comment out this stuff. This is all stuff we shouldn't do. All right, so there we go. Done simply for the sake of understanding. How do you truly understand something unless you have tried all of the possibilities that are good ideas and bad ideas? My 9-year-old has a far enhanced sense of what electricity is since she tried to plug in a string of Christmas lights and managed to shock herself. She was very upset when she came up. She really thought she was dying. And ever since then, for a while, she wouldn't plug anything in at all. You know, the fingers stay back on the plug somewhere safe. I didn't know you could do that until I had kids. I thought they'd engineered plugs so that the prongs were insufficiently long to get your finger in there.
Oh, you can.
Yeah, you totally can. Especially if you're 6 or, well, she was like 8 at the time.
Small fingers.
She's 9 now. No, she's 8 now. She's 7. Oh, who knows what age she was.
Lisa, your wife is so disappointed right
But I think she's been all these ages.
Yeah, really? Wow.
What a dad.
All right. There we go. So coming back to stuff that you should actually do. If you want to return a pointer with this kind of thing, this is fine. There's plenty of other data structures that do this. It does allow efficient use of the pointer in some cases. If you really want to change a class's internal data and you're writing the program, you can figure out a way to do it. It just requires sufficient creativity and an understanding that whatever consequences that you encounter will probably be fine. That's where I'd recommend it. Jesse McDonald, who I don't know if any of you guys remember, he graduated and he moved on to, you're nodding like you remember him, very large, carried around a jug. The jug had a duct tape strap that went around his backpack. I used to call him Jesse the Jug, because he carried around the jug, although they said he was actually a juggernaut. One day he opened the jug, and I was expecting, you know, he had like a jug full of water or anything. So he opened the jug, and he took out this plastic bag full of these big metal balls that were all rusty. like ball bearings from some piece of heavy equipment or something. And he put them all in the freezer, and his idea was these steel ball bearings would keep his drink cold but not too cold. Apparently ice was too cold. So he's just going to use frozen steel balls instead, but they rusted inside his plastic bag. I don't know if they sweated or if the bag leaked.
Steel works.
Yeah, anyway. So, all right. So there's a good introduction to Jesse for you, because the other thing I'll tell you about him is one day he came in to ask me a question. People ask me questions all the time. Usually they ask something like, my assignment isn't compiling. Well, he asked me a question. He's like, so I have a class that I wrote, and one of the methods on the class, I actually want to delete and deallocate the class and then reallocate it and have the this pointer change. So he worked out a way that he thought would work, and it didn't work for some reason. I don't remember why.
Wait, did he still carry the plastic jug with the duct tape?
Yeah. I don't know what. He lives in Hawaii now. He might not have taken it with him. I don't know.
He's 1 year older than me, I think. Because I was with him in high school too.
Really?
That jug is from high school.
Oh, I didn't know that.
I'm dead serious. I'm dead serious. If it's the same jug, then is that.
Why not just a plastic jug? It probably holds a gallon or so.
Yeah, is it like a yellow cap?
Yeah.
Or an orange cap?
I don't remember what color it is, but it has a thing that you open so you can fill up cups or whatever. But he's always just like.
Is that jug?
All right, thanks for filling in the detail. I didn't know. That's awesome. All right, well, I'm about out of time now. I'm just joking about what people have done with classes. Now, the serious part of this is to inspire you to make classes that are simple and easy to use. But you're in college right now. You don't have a boss at your company or a code review. All you have is me, and it's my job to figure out whatever you turned in and why it doesn't work. So, enjoy life as a college student. You can do all kinds of crazy things with memory addresses.
Enjoy working.